Good morning, everyone. My name is Runar Aasen. I'm here, happy to be here from BS Engineering. I work with Shipweight and weight control. I've been doing this for more than 20 years, started in 1996. And I'd like to present how and discuss the challenges utilizing weight and center of gravity information in the CAD model, and then show how we overcome at least some of these by when we import weight data from ShipConstructor to Shipweight. Okay, so weight control. Some will say, and maybe especially on the upper management, that what do you mean weight control? You got the CAD model. The CAD model is your weight and your weight control. Well, it's not. For numerous reasons, it's not. I could talk a lot about that, but I'll just mention two of the important reasons why not. One is that weight control starts in the second that someone calls you and say, I'd like to have a vessel going from A to B with this load. That's when weight control starts. And most likely, you don't have the CAD model for that vessel right there and then. The other reason is that at the end of the project, before inclining test, the approximation test, you have the CAD model, but you shouldn't use it. You should use the weighed weights from the yard. Why? Because if your CAD model says it's going to be 10 millimeter plate thickness, that's of little help if the workers in the yard decided that, oh, we don't have 10 millimeters in stock, but we have 12 millimeters, let's use that. The classification society is happy because it just adds strength, but it's not good for a weight model. The other reason is that your CAD model doesn't have all your weights, very simple. It doesn't have your equipment weights, it doesn't have electrical weights. It has, hopefully, most of your structural weights. That being said, of course, there is a certain period in the project where your CAD model is a very important source of weight and CG information. And of course, you should utilize this. But again, it may not be as straightforward as you think. So you need to do it in a smart way, and you need to think about it. And I'm going to just discuss a few of the challenges and then show how we do this going from ShipConstructor to Shipweight, which is a weight model tool. Right, first thing, your CAD model is limited. There are some limitations of the weight data, and you need to ask yourself at least two questions. One, what weight data is available in the 3D model? And two, what is the quality of the data in the 3D model? The person who is drawing in the 3D model, is he thinking about weight at all? Or is he just drawing a solid cable tray because that was most convenient and it works well on the drawing? Might not work so well in the weight model. So make sure that you know what is in the weight model and what is the quality of it. And just to emphasize really about what data is available, it's important to remember that it's equally important to know what is not present as to know what is present, okay? Second thing to think about, what do we want to get from the weight model, from the CAD model to the weight model? Do we want a staircase like this? Do we want that in as one item? Or do we want the steps and the rails and all the small nuts and bolts? And I would say, in general, keep it as simple as possible. But not simpler. It's easy to fool yourself by just dumping a lot of data into the weight model and believing because that gives you a false sense of accuracy. You know, I have 300,000 lines in my weight model. This has got to be super accurate. I must have accounted for everything. Well, you haven't. And it's much more valuable if you can go into a weight model and read a line and know what this is instantly than just to go in and see a line about a bolt or a nut or something that you really can't say much about. And also, talking about what to get from the model, obviously you want the weight and the center of gravity. But maybe there's other things you want to get as well. Obviously, you may want to get the material type, if that is present. There could be other things. Vendor information or drawing numbers. Depends what's available. So think through what is available and decide then what I want to extract. Finally, there are some special challenges. One is deleted items. If someone deletes an item in the CAD model, you must make sure that this is also deleted out of the weight model, or else obviously things would stock up and you would pretty soon be overweight. This needs to be accounted for when you're updating. The other thing is temporary items. Someone decided to draw something, just do some temporary work, and because it's going to be temporary, they put it out in space far away from the vessel, and they forget to delete it, and it just sits there. It gets into the weight model, and it throws off your center of gravity. And finally, the work breakdown structure, which is, I think, the biggest challenge of all. If you are going to be able to utilize weight data in the future in a good way, and if you're going to do good weight monitoring and tracking, you need to assign your weight data to some sort of work breakdown structure. Okay? And this is often possible in the CAD system. I know it's possible in ShipConstructor, but many times it's not being done. Okay. We participated a few years ago in an NSRP project in the US, which was called Leveraging Detailed Design Data in Weight Engineering. And DRS Technology in the US was project lead. We were involved, ShipConstructor was involved, and Marinette Marine Corporation in the US and VT Halter in the US were two yards that were involved. We were looking into these challenges that I just presented very briefly more in detail. And out of this project came a middleware which was called Fulcrum 3D, which some of you might have heard of. And this was the basis for the solution that we have implemented directly in Shipweight. We were able to connect to the Fulcrum 3D and import the ShipConstructor data through Fulcrum 3D. But now in the newest version of Shipweight, we can skip that and import it directly. And this is how. It all starts with a smart export from ShipConstructor. Publisher LT is set up to export two TSV files. One of the current parts in the model where you have the part GUID, very important. You have part name, drawing number, description, weight, center of gravity, and other columns that you want to get into your weight model. The second file is simply a list of deleted items referenced by their part GUID and created date and a deleted date. And this, of course, goes to what I mentioned about the importance of accounting for deleted items. Then we have a smart import to Shipweight. So in Shipweight, we have a user interface for importing these two TSV files, which basically consists of three things. One, okay, you browse and point to the TSV files. That's easy. You point to the parts file, and you point to the deleted parts file. Then we have a way of setting CG boundaries, and this is a very simple way of just making sure that you're not importing some items that's off the boundaries of your project. We also have other ways of checking this within Shipweight later, but I'm not going to go into that. Then we have a mapping file. These TSV files that you get from Publisher LT isn't static. They can be designed to fit the needs of your organization. And this means that we must also be able in Shipweight to adapt to however the TSV files is set up. So we have something called an XML mapping file in Shipweight that we can load and that knows how to interpret the TSV files. When that's done, basically you click the button, import, and Shipweight will import and update your model. To summarize what happens when you import. First, of course, it imports and updates parts. New parts are added, and existing parts are updated. We also update the deleted parts by the GUID. If we have a list of the GUIDs of the parts that's been deleted, of course, we must delete them out of the weight model, and this is done automatically. We have the global boundary settings. We have the GUID identification. And then we have two things that will help you simplify the reporting. We get in assembly information and like parts information. This means that you have the possibility to import all the details, but in the reporting, roll up to the assemblies so it's easier to check and verify the import and the results. And we have the like part reporting possibility, which means that identical parts can, in the reporting, be summarized to just one line and a number of the like parts instead of having a long list of very small, tiny parts. And finally, we're editing. I mean, the updates are edited in a smart way, which means that in the weight model, in Shipweight, if there are parts coming in without a SWIBIS, and the weight engineer goes ahead and assigns SWIBIS numbers, work breakdown numbers to the parts, it's of course very important that the next time the update happens, that work is not lost. So we are a little bit selective in the update process. The user we can say something in the XML import file about when you do updates, are there certain fields that the update should leave their hands out of, so to speak, not touch. And obviously the work breakdown structure identification is one, it could be others. That's it. I just run it off by saying that the difference between taking some time, whether you use Shipweight or not, to think through these things and be smart about it, the difference between doing that and not doing it just a little bit at least, and not doing it at all, that could be a big change for your project and accuracy of a weight and CG model.